Hello. Uh, it's so good to be here talking to you, all of you in person. This is like my first talk in person post COVID, so pretty excited about it. A little bit about myself. I'm originally from Pakistan and have been here in Estonia for almost like 5 years now. I have recently finished my PhD in the domain of green software engineering and have joined the faculty now in the University of Tartu. So, green software engineering. Today I'm going to tell you what, why, how of this field a little bit. And it's like an emerging discipline, and it is one of the dimensions of software sustainability. And it involves all those principles and practices to develop and maintain a software in a way that it have minimum negative impact on the environment. And in this talk, I would focus and will try to give you a glimpse into the research related to green software engineering that we are doing at the Software Engineering and Information System Group at the University of Tartu. Mostly particularly related to the mobile app development. And the motivation behind this research is to contribute to the reduction of the CO2 emissions that is related to the ICT industry, and to create awareness among software practitioners that the energy consumption of the software should be considered when they are making different types of quality trade-offs. So, why? Why software engineering? Because we have seen that the global warming due to CO2 emissions have become like one of the most prominent environmental issues. It's rather difficult to come by on the latest studies on this particular area because it's hard to gather the data, but the recent one that I have seen is in like 2019, which places the ICT industry to account for like 8% of the global electricity usage. And we can compare it to almost to the aviation industry. And during the pandemic, the past 2 years, we have seen a lot of discussion on how the environment have improved, and with the no flying, and should we fly green or not, but not so much discussion on how you watching videos all day on YouTube and Netflix affects the environment. And within the past 2 years, with the pandemic and everything, it's also, there's like a complete boom of IT services. We have been using more and more of those services. But the problem is that the more we, every minute that we spend on our devices consuming those services, adds up to the CO2 emissions. But it's truthfully quite challenging to put a number on it, to give you an accurate prediction of the global ICT electric power usage, because it's problematic to account for all the unknown variables. And depending on where in the world you are, the cost of electricity usage, it could be low or it could be high. I got this map from this website, Electricity Map, which kind of gives you the real time data about the electricity in specific areas, and that where it comes from and how much carbon emission that goes into when producing it. And of all the CO2 emissions, 41% is caused by the electricity production. And more than 40% of the electricity produced globally is produced using combustible fuels. And you can see in the picture still that the gray areas we have still not enough data. And with the green ones are very few and far. So these are the areas that are somewhat moving towards or in the zone that we want to acquire in terms of carbon neutrality. And the rest are pretty much not there yet. So every small step that we can take towards this global carbon neutrality targets that counts. And more with in our everyday life, like we are using more and more portable devices now, and the mobile phones are the most commonly used. And since these devices are battery operated, they are constrained by this particular resource. And it's a crucial parameter when users go for a device, right? So in order to produce energy efficient devices, the software architecture, design, and code, they all need to be produced in a way that the ending product is green or energy efficient. However, the software practitioners lack the necessary information and the support infrastructure to produce these green software. And we can provide, as researchers, this information via software analytics, which combines this information from various artifacts and convert it into something useful that the developers can use. So, what to measure? To physically measure a software energy consumption, we can measure the power consumption of the hardware over time while it executes a software task. So let us consider a very simple scenario. For example, let's say I want to download 1 MB of data from the server over 100 times. So it's like one of the very common functionalities to have in any of the app nowadays. You want to upload things, you want to download things, you are sending data, and you're doing it over and over again. And the most common mechanism behind this kind of functionality is the HTTP GET requests. And usually, when we are developing apps, there are a lot of alternative libraries available to implement such functionalities, because developers use this to speed up the process. And if you are not aware about these third-party libraries, these are like reusable components that you put into your app code, and which gives you the functionality, so it's kind of saves user time, right? And but the task of choosing the right thing is not so trivial, because the libraries, if they are included into the app once, it takes a lot, might not be updated so soon, right? So developers spend a lot of time selecting these libraries and comparing different specs related to these libraries. And there are online catalogs and online repositories where you can find millions of these libraries. But what information you do not find there is how efficient is a library, energy efficient it is. And imagine doing all that work, right? And then you end up with an app that drains battery. So what we want to measure is that when we make such selections, we want to know, okay, if library A, the version of my app where I used library A, was that more energy efficient, or the version where I put the alternative, was that more energy efficient? So how can we do this? There are many approaches to it. There are software-based approaches and hardware-based approaches. With software-based approaches, which sounds good, are easier to implement, but they are mostly estimates of your system calls, of how much data you have sent over the network, and could be like CPU cycles or something. But so they are not very accurate. On the other hand, the hardware-based approaches, they are difficult to set up. There is physical measurement devices involved in that setup. And but once you are over that one-time setup, the measurements that you gather from there are quite accurate. So for our research at the University of Tartu, we use this hardware-based setup to measure energy consumption. And the main typical process of this energy measurement process involves 4 main steps. You collect data, you pre-process it, you do statistical analysis, and then you visualize, right? So first, like over here, we have 2 versions of the app, right? So what we do is we create versions of the app. We create all those alternatives that we want to measure. And then we create tests for those app versions, which mimic the user interactions in the real, in a particular use case. And then we run those, can I use the pointer? Oh, yeah. So then we make this application versions, and then we run those test scenarios on a cell phone. And then while it's running, we capture the energy data via some kind of physical measurement device, in which, in our case, is a monsoon power monitors, which almost takes like 5,000 readings per second. And then from there, we collect the ADB logs, energy readings, and then we filter this out with the timestamp matching to know exactly when was this scenario running and when was it ending, and then we do statistical analysis, and then we compare the energy, and then we try to see that which option is more better in terms of energy efficiency. But as you saw, this process is quite lengthy, and it's resource intensive, and it needs time. So what happens? So what we did was that we created this arena tool to help fellow researchers like myself to make their life a little bit easier. And it automates all this process that I just shown you, this one. So it kind of automates this and helps you take the energy measurements in a reliable way and in a consistent way. Because when you are doing all this process, there could be a lot of things that could affect the measurements. It could be the room temperature, the hardware temperature. It's the way you, the order in which you execute stuff. It could be the background processes running on the phone. It could be the underlying variations in the devices. So there's a lot of things that that need check and balance when you are doing these measurements, and this is what helps you with it. So we have built it as a IntelliJ and Android Studio plugin, and it's open source, and you can further develop it and tweak it to your needs. Yeah, and over here you can set up, you can set up these certain parameters, and it makes your life a little bit easier. That's the point. So now I have all this energy data. I know what I can measure. I know it's important. But as a developer, what do I do with it? What now? So basically, as a developer, you might be thinking, like, why would I set this up? Like, where would I use this? Well, the next logical step for this data to make any sense to the developers for whom we are trying to make their life easier is to build support tools and recommenders based on this data, so that they don't have to do the manual effort and try to interpret what we are trying to tell them here. So to help them in this direction, we created another tool, which is called Rehab. And it's also open source, and it is useful in identifying third-party HTTP libraries in Android applications. And what it does is that the code inspection modules detects the third-party libraries via call expressions and methods included in the project, and then based on the energy data, it kind of recommends, look, you are using this library, but there are also alternatives available which are much more energy efficient than the one you are already using. So the point is to inform the developer, right, so that they can make informed decisions. We just want to put energy efficiency of these libraries into the mix, so that when they are considering the trade-offs, they at least consider that this also matters. So at the moment, because you might be aware that there are like millions of libraries out there in the Maven repository alone, and we have done a very small subset of those. So at the moment, I will admit that this is like a very like a prototype tool, and the scope is limited, but it has potential. So if you have more energy data, we can expand it to include more libraries and more recommendations in more use cases. Okay, having said that, then what's the way forward? Because if you are a developer, you must be thinking that why would because I'm trying to relate this to the real life development environment, and trying to convince you a little bit that that you should consider this. And one thing is for sure, that the measurement process, as I have described, is lengthy. As a developer, you might be skeptical. You're like, oh, why? Not so. Until and unless the user is not saying something, or my client is not saying something, so why bother? And the reason is this, because we don't have tools to make our life easier in the process. So to move forward in this domain, the first and the foremost thing that I think is to educate and motivate the software practitioners that this is important. Because with technologies like artificial intelligence and virtual reality and augmented reality, which does come with some types of battery constraints when you're using such devices, energy consumption is important. And to offer like a global solution, because right now we don't have any. So, and there are very few people who are doing this kind of energy measurements and energy data, trying to provide it for the developers. And because this data is not available for every context, sometimes developers are just frustrated with this whole idea. So to move into that direction, where we have more energy data for these software-based prediction models, and where we have more data for different or better trade-off analysis with other non-functional requirements in your applications, I would suggest going towards energy measurement as a service. Because first of all, the power monitor tools, they are complex and impractical for developers to use in their real environment. And they would ask, why can't we use a software-based measurement model? Because those models need continuous updates. And those updates can only be provided if you have the data from the hardware-based process. So aren't we in a pickle, right? So reliable energy data is lacking. And the context in which a given energy model can provide reliable measurement is not always clear. So I think the next best solution, or the research area, is to provide this energy measurement as a service. And I think this is a very good business idea as well. So to all the people who are here from the industry and the potential students, I would like you to comment on this after I have finished my talk. That what do you think? Is it viable? So if there's a startup, let's say, and they are offering energy measurements as a service, right? And you as a client, people in the industry for whom this service is being offered, what are your expectations of it? What do you think? And in what scenarios would you like to use these services? So something to think about. And to wrap it up, I would try to convince you one more time to participate in this kind of research and to develop solutions in this area by quoting the words of Morpheus from the first Matrix movie. In which he says, so I'm going to mold it a little to say, take the green pill, and then we can explore together and see how deep the rabbit hole goes. Thank you.